Yes, you need to find the free body diagram for this and get the acceleration of the system. That's the question, first question. And the next question is tension in the string, and the last question is extension, like what is the x value I need to find. Okay, so let us start with the free body diagram. Okay, so we know that spring force is kx. Okay, so if I draw the free body diagram for the block C, block C. So towards down it is mass of the block and the gravity, that is weight, so mass of block C and the gravity, and towards up will be my spring force, obviously. So this is my acceleration direction, yes, this is 1 kg, this is 1 kg, and this is 2 plus v, 5 kg. So in which direction object will move on? So in the direction of where the masses are more, right? So this is the direction of acceleration and the force, spring force. So what will be the equation now? So equation will be mass is 3, so 3g minus kx equals to 3a. Okay, this is the thing. Now what is the block 2 is having? Block 2, if I see, I mean block B, right? Block B. So block B is having a mass B and gravity, that is weight. So mBg, and then a spring force is also is there, so towards down, and tension is there towards up. So this is my rope and this is my spring, so tension. So now the equation will be, what is the mass here? 2 kg, right? Okay. Second equation is 2g plus kx minus t will be equals to 2a. That's it. So this is my first equation for the block C and second equation of the block B. Now the third equation of block A. So block A is having a tension, and this is A, and acceleration in this direction. So T will be equals to 1a. That's it. So can I write like this? T is equals to a. That's it. So this is my equation 3. So is there any doubt in this equations? So why the acceleration acts downwards? So if I consider this is 1 kg and this is 2 plus 3, 5 kg, so where mass is more, 1 kg or 5 kg? So 5 kg. So in which direction the block will move? Towards down, So this one also will move in this direction, right side, and the blocks will go downwards. Hope you got it, Tirupati, yeah, you got it, Fine. Now these are the equations from the free body diagram we got. Now let me add these equations. So if I add now, what will happen? Plus t minus t will get cancelled off, plus kx and minus kx will get cancelled off, right? Yes. Now if I take, I mean adding, so 3g plus 2g, 5g is equals to 3a plus 2a plus a. So 5a, 6a, so 6a. So 5 into 10 divided by 6 equals to acceleration, where acceleration will be equals to 50 by 6 meter per second square. So this is my answer for the acceleration of the first question. Yes, So first question has been completed now. So acceleration is 50 meter per second square. So tension in the string they are asking. So from this 3 equation only I will consider, okay, the question is asking. So I got acceleration first. I need to find the tension. So any of the equation I can use to find the tension. So if I consider first equation, excuse me. Yeah. So if I consider first equation, only kx, like spring force is there. When I consider second equation, spring force and tension also is there. And if a third equation is there, t is equals to a. Directly I can get it the value of tension, So tension is nothing but like mass 1 kg obviously, and acceleration 50 by 6. So 50 by 6 Newton is the answer for the tension. So 50 by 6. So this also 50 by 6, sorry. Acceleration also 50 by 6 and tension is also 50 by 6. So what about the extension? Extension in this spring. So they have given the value of K. So any of this equation, like either first equation or second equation, I can use and get the value of X, right? No? Yes. So let me take this. 3G minus Kx equals to 3A. So 3G, wait a minute, yeah. 3G minus Kx equals to 3A, no? Let me take this one, yeah. So what is the value of K? K is given as 15 Newton per meter, no? Yes, no? And what is the value of A? A is equals to 50 by 6 meter per second square, no? And what is the value of G? G we know, G is equals to 10 meter per second square. They have given to use that one, right? No? So now I'll take this equation, 3 into 10 minus 50x equals to 3 into 50 by 6. Okay, so 30 minus this 2 times and this 1 time. So 50 by 2 is equals to 50x, right? No, 50x. So 2 times, so 60 minus 50 by 2 is equals to, yes, x, 50x, no, yes, 50x. So 10 by 2, no, 10 by 2 is equals to 50x, x. Okay. So let me take this one. So 0, 0 will get cancelled off. So 1 by 10 will be equals to x. So 0.1 meter will be equals to x. That's it. So everything in meter, no. So we got the final answer is also in meter. So 0.1 meter is the extension happen when the value of K is 50 Newton per meter. Okay. So totally 3 things they have asked. One thing is acceleration of the system and tension in the string, and what is the extension happen when the force is given, like spring force. Yeah, so spring force constant has been given. Okay. No. It is 0.1 meter. Okay, we'll go for the next one. Next question we'll see. So the next question is, a box of mass 5 kg is pulled by a cord up along a frictionless plane, that is inclined plane they have mentioned here. Okay, let me mark that as inclined plane. Okay, they have given it is inclined plane of 30 degree with the horizontal. The tension in the cord is 30 Newton. The acceleration of box is. So they are asking about the acceleration of the box, no? So I need to find what is the acceleration. So let me take it, the inclined plane first. So inclined plane will be like this, no? A block has been kept there, a box has been kept there. So now this one will be my theta, which is 30 degree they have given. So when we draw the free body diagram, let me consider this is mass m. So they have given the mass 5 kg, okay, mass m let me consider. So this one will be my weight mg and this one will be my normal n. Okay, so what about this one? This is my mg cos theta. So yesterday, in last class, we have talked about how to take the components for inclined plane, okay. So this is my mg sin theta. Okay, now what they are saying is pulled by a cord up along a frictionless plane inclined at a 30 degree with the horizontal. The tension in the cord is 30 Newton. So suppose if I find what is the force acting over here, so I can say that in which direction the object is moving, no? Yes, obviously. So mg sin theta sin 30 degree is equals to, what is the mass? 5, and what is the gravity? 10, and sin 30 is 1 by 2, right? No, So once, and this is 5 times. So 25 Newton. 25 Newton. So which is greater here? 30 Newton or 25 Newton? Obviously 30 Newton is greater. So in which direction it will go? In the direction of where the force is more. So can I write like this? So tension minus mg sin theta is equals to mass into acceleration. That's it. This is my equation. So tension, like chord will be there. So tension will be in this direction. So object is moving in this direction if at 30 Newton and 25 Newton acts there, right? No. So this is 30 minus 25 divided by 5. Mass is 5 equals to acceleration. So 5 by 5, no. That's it, no. 5 by 5. So A will be equals to 1 meter per second square. That's it. This is my answer. Okay, so the next question will be somewhat tricky here. We'll see that. Can we see that question? Okay. Okay. Tirupati, yes, it's 1. Yeah, you are correct. So the next question I have displayed here now. So two blocks of 7 kg and 5 kg are connected by a heavy rope of mass. So till now what we have seen, whenever we are considering the rope, no, the rope is massless, right? No. So now we are considering a rope of a mass 4 kg now. So an upward force 200 Newton is applied as shown in the given diagram. The tension at the top of the rope is, they are asking what is the tension at the top of the rope here. So this is the tension, in this point what is the tension they are asking. Okay, so can you give answer for this question? Okay, can we do? So whoever got the answer, no, keep the answer with you and cross verify the answer once. Okay, so two blocks, no, so they have given the two blocks of mass 7 kg 5 kg. Okay, let me find what is the weight over here. Okay, so first of all, when they are giving like this kind of question, no, assume it as a whole system like 7 kg plus 4 kg plus 5 kg, which is 12 and 16, no, 16 kg blocks are there and 200 Newton has been applied to lift over there. So which means this is total system. I am considering it as a total system now. So total system in the sense this is having a mass 16 kg. Let me write here. So 16 kg block is there. 16 kg blocks I have taken and I have applied a force 200 Newton. Will I able to lift that by applying 200 Newton? Let me check it first because the weight I need to find, no, what will be the weight? Yes, so weight will be 16g, which is nothing but 16 into 10, 160 Newton. Yes, obviously I can able to lift. So 160 Newton only, but I am applying 200 Newton here. So obviously the block will go up. This is my acceleration, direction of acceleration. Yes, it is 112.5 Newton. Yes, fine. Okay, so this will be my acceleration direction. No, so let me find what is the acceleration first. So 200 minus 160, 200 minus 160 will be equals to 16a. Right now, so 40 by 16 will be equals to a. Right now, this is my acceleration. So this is 8 times and this is 20. Right? No? Correct only, no? Yeah, fine. Or let me take it as in a like a 4 table also. This is 2 times and this is 5 times and this is 1 and this is 2.5. So A will be equals to 2.5 meter per second square. That's it. Right now? I got my acceleration now. So let me take now, this is one block and this is another block and they have tied with a string now. So let me take like this. So this is my block, 7 kg block, okay, and I have applied some force over here. Now I have tied with a string or a rope here. Now this total system including the rope and the block, which is 9 kg. So this is 9 kg, right now. So now what will be the tension over here? That's the force they are asking, no, the tension they are asking, right? No. So this is my 9g, this is my t, and towards up the acceleration. So t minus 9g is equals to 9a. That's it. So t will be equals to 9g plus 9a. So this is 9 into 10 plus 9 into 2.5. So answer will be, yes, 112.5 Newton is the answer. That's it. Option B is the answer. Okay, we'll go for the next one. Fine. So next one is a friction. Okay. So what is the meaning of friction? Like it's a kind of force. Okay, a friction is a kind of force which is opposing my external force. If I apply something, if I apply some external force, it will try to reduce because something is opposing me. Okay, something is opposing me. Like frictional force opposes a relative motion between two surfaces when they are in contact. Okay, so objects are in contact, then only the friction force will be acting. A person is applying a force over here. Okay, and the friction force will be like when the surface is rough, when the surface is smooth, there is no friction. There is no, when the surface is rough, the friction will be taken place there, right now. So whatever the force we are applying now, some external here force is acting, that is opposing force we'll say. Okay, so now the properties of frictional force, it is directed opposite to the relative motion, first point. Okay, whenever I am applying a force, it is opposite to the applying force, right now. Second point, it is parallel to the contact surface. So it is parallel only to the contact surface, yes. So it is proportional to the normal reaction. So if I take object having a mass 1 kg, object having a mass 5 kg, same friction surface, same rough surface, this is the rough surface, let me assume. Let me take one 1 kg block and one more 5 kg block. I am applying a force F1, here also I am applying a force F1. So in this case what happens is F1 is equals to 5 Newton, this also F1 is equals to 5 Newton only. So if I apply two blocks, apply force on two blocks, which one will move fast? 1 kg block. Yes or no? So why it's moving fast? The friction acting over 1 kg will be lesser than the friction acting over the 5 kg. So when what I can say here, it's directly proportional to the normal reaction. Yes, no? So friction is directly proportional to the normal force. Okay? So it may or may not be depends on the area of contact. So it's may or may not be depend, but it's depend on the normal force. Okay, so what will be the formula? F is the friction force denoted like small f. Let me consider small f will be denoted for the friction. So F is directly proportional to the normal, and to remove the proportionality I am adding a constant called mu. So mu n. So this is the formula for the friction. Okay. So mu is nothing but coefficient of friction, will say coefficient of friction. So whether this coefficient of friction is having any units? No. Friction is a force, normal is a force. So friction by normal will be again, yes, like units will be get cancelled off. So coefficient of friction will be doesn't have any SI units. Okay. Copy down first. Done. Will you go for the next one? Okay. Yeah. So when we are talking about the friction, no, there are three types. So one is static friction, second one is a kinetic friction, and third one is a rolling friction. So first we'll see what is the things here. So first we'll see the two things, one is static and one is kinetic. So static friction is nothing but a force that opposes the start of motion between the two surfaces. So there is a block over here. Okay, this is the block. Let me consider. A force which is opposing the start of motion is nothing but static friction. What about the kinetic friction? The frictional force that opposes the relative motion. So object is moving now. Okay, when the object is moving, when the force is opposing, no, that one I'll say as kinetic friction. So object is at rest, I am applying some force to start the object. So the two difference between them is opposes the start of motion, opposes the relative motion. Okay. So condition, static friction acts when the body is at rest. Okay, and acts when a body is sliding or moving to the relative to the surface. Okay. So two conditions are there, one condition is at rest, one condition is in the relative motion. So opposes the start, opposes the relative motion, and body is at rest and body is sliding or moving relative. Done. So we'll see the formulas now. So these formulas will be similar only. Okay. So we know that F is equals to mu into N, where N is equals to mg, no? Yes, no, N will be mg. So friction force will be mu mg. This is the formula we got. Now C for the static friction denoted by F, S. So static friction opposes the impending motion, that is motion that would not take place. A motion should not take place. I am opposing the force, I am applying the force, a force is opposing me to not take in the, not go in the motion, that is the static friction. Okay. So the formula will be mu mg, same only. So the coefficient of static friction will be given in the equations. Okay. Done? Okay. So now for the kinetic friction. Okay. So if F is greater than a static friction, so the applying force, I'm applying some force now. If that applying force is greater than the static friction, now what happens? I'm applying some force. The opposing force is there. I am applying some 10 Newton force, opposing force is 5 Newton. What happens? Object will move now, which means in that time kinetic friction takes place. Okay. So body begins to slide on the surface. Now we have the frictional force that opposes the actual relative motion. So which is kinetic friction, which is directly proportional to the normal. So same formula only, but the terms only will be different. So kinetic friction will be equals to coefficient of kinetic friction and the normal. Done? Okay. So there is the question, I mentioned the answer, okay fine. So determine the maximum acceleration of a train in which a box lying on the floor. So there is a train, guys, okay, don't see the answer, leave about the answer. There is a train. So inside a train a box is there, okay, a box they have kept, or let me take there is a bus or any vehicle. So inside a vehicle I kept a small box over there. So what they are saying is box lying on the floor will remain stationary given that coefficient of static friction between the box and the train is 0.15. So which is mu is equals to 0.15. Okay, no? Okay. So I need to find what is the acceleration, no, maximum acceleration, and they are saying that static, no? Yes. So what happens here? Object is going in this direction, which means a force is applied in this direction, no? Is it? Yes, no? And opposing force will be in this direction, yes, no? So force and this is static friction and acceleration. So if I write the equation, what will I write? F minus static friction will be equals to mass into acceleration, right? No? That's it, no? So what is the force? I'll keep F as it is, right? No. So MA will be what? Frictional. Tell me what will be my MA? Yes. F minus Fs. So here the mass into acceleration. So the maximum acceleration they are asking. So this is ma will be equals to mu into n. No, that's it. No. So ma will be equals to what is n? Mg. I'll substitute the value here. That's it. So will get cancelled. So A max I need to find. What is the maximum acceleration I can use? So mu, what is the value of mu? 0.15 into 10. That's it. See, the thing is, what we have written first of all, F minus frictional force will be equals to mass into acceleration, right? No. Now what they are saying, a static friction, no, static friction in the sense the force which I am applying will be equal to the opposing force, no, yes, no. So that's why I will take friction will be equals to the mass into acceleration, that's it. Done?
But acceleration,
which one? I am calculating maximum acceleration, so the box will remain stationary. Got it? So this equation when I am using, when I am using this equation means object is in relative motion and I am opposing, which means in that case I am using the kinetic friction. It is static friction. Got it? So static friction in the sense train is moving and boxes remain stationary. So if train is moving with some acceleration, so what will be the acceleration? The box will remain stationary. Got it? So if a box, if a train is going more than 1.5 meter per second, the box will start moving. Got it? Got the point? No? Okay. We'll see next question. So here is the question. A mass of 4 kg rests on a horizontal plane. The plane is gradually inclined until an angle of 15 degree. Okay. So let me take this angle as theta equals to 30 degree. Okay. I have taken 30 degree. The mass just begins to slide. Begins to slide in the sense which friction now will act? So what is the coefficient of the static friction between the block and the surface now? You are saying kinetic. Begins, no, it's just starting begun. It just started, which means a static. It's going means I can say it's a kinetic. It just started. Okay. So this is a force going down, which is mg sin theta. Frictional force will be in this direction, maximum frictional force. Yes or no? And a normal force will not be equals to mg, which will be equals to mg cos theta. Right? No. If I take the component, this is my cos theta and this is my sin theta. No, that's why I have written there. Right? No. Now get the answer. Same thing. What they are saying, just started begun. So F will be equals to mg sin theta. So what is F here? Mu into n mg sin theta. Right now. So what is n? Mg cos theta will be equals to mg sin theta. Mg and mg will get cancelled off. Yes, no? They are asking what is the coefficient of static friction. So mu will be equals to sin theta by cos theta will be equals to tan 30 degree. What is tan 30 degree? Give the answer. Yes, that's it. Okay. See, Papri Basu. Okay, repeat the process. Okay, fine. See, here what they are saying is a mass of 4 kg at rest, okay, on the horizontal plane. So the plane is gradually inclined until an angle 30 degree. With the horizontal, the mass just begins to slide. Just begin to slide. No. So what will be the coefficient of static friction between the block and the surface? So whatever the force I am applying will be equals to the static friction, like maximum static friction. So that's why I have written. So Fs will be equals to mg sin theta. Okay, this is the force which is helping me to go down. No, yes, no. So mg sin theta. What will be F? F is nothing but mu into n, where n is mg cos theta. So I have substituted the value here. So and we got the mu value. Okay. Okay, so with this we'll stop the class, okay, and we'll see the next topic in the upcoming sessions. Okay, we'll meet in the next class, guys. Bye. Intra problems here.